Hi, welcome to General Mathematics class. Continuing the lesson on functions, today's topic is evaluation of functions. So how do we evaluate functions? In order to understand evaluation of functions, let's take a look at this example. Below is the current price list of meat selections in the city public market. Chicken, represented by letter C, is priced at 150 pesos per kilogram. Pork, represented by letter P, is priced at 200 pesos per kilogram. And beef, represented by letter B, is priced at 220 pesos per kilogram. Suppose your mother asked you to buy 1 kilogram of chicken, 2 kilograms of pork, and 3 kilograms of beef. How much should be the budget for that? We use the expression 1C plus 2P plus 3B to represent the situation. Using the price list, we substitute C with 150, P with 200, and B with 220. Hence, we have 1 times 150 plus 2 times 200 plus 3 times 220. Simplifying, we have 150 plus 400 plus 660, giving us the total answer of 1,210. Suppose last week the price is actually way higher, wherein the chicken is priced at 180 pesos per kilogram, pork is priced at 220 pesos per kilogram, and beef is priced at 250 pesos per kilogram. Using the price list from last week, how much could have been the budget? So we use again the expression 1C plus 2P plus 3B to represent the situation. And since the price list is now different, C will now be substituted by 180, P will be substituted by 220, and B will be substituted by 250. Simplifying, we have 180 plus 440 plus 750. The budget, if we use the price list from last week, should have been 1,370 pesos. How then do we evaluate functions? To evaluate a given function f of x, it's actually the same as computing the function value given the value of the variable x by substituting this value of a function. Earlier, we just used the letters C, P, and B to represent the chicken, the pork, and beef respectively. Since we are now talking about functions, only the variable x will be used. This means, in order to evaluate a function, we apply the law of substitution. The next example is a function wherein the function of x is equal to 2 times x squared minus 3x plus 4, and we need to evaluate this function when x is equal to 2. By substitution, f of 2 is equal to 2 times 2, which was originally an x, squared, minus 3 times 2, which again was originally an x, plus 4. Simplifying, we have f of 2 is equal to 2 times 4 minus 6 plus 4. Simplifying further, we have f of 2 is equal to 8 minus 6 plus 4. We have f of 2 is equal to 2 plus 4. And finally, our answer is f of 2 is equal to 6. This means that the value of the function when x is equal to 2 is 6. In another example, we have f of x is equal to 32x cubed plus 8x squared minus 4x plus 3, and we need to evaluate this if x is equal to 1/2. Following the method of the previous example, we need to substitute first, giving us f of 1/2 is equal to 32 times 1/2 cubed plus 8 times 1/2 squared minus 4 times 1/2 plus 3. Then reviewing the PEMDAS rule, since the exponent is directly outside the parenthesis, the exponent should be given emphasis first. So our first simplification of this is f of 1/2 is equal to 32 times 1 over 8 plus 8 times 1/4 minus 2 plus 3. Simplifying further, f of 1/2 is equal to 4 plus 2 minus 2 plus 3. Finally, our f of 1/2 is equal to 7. Our last sample function for today is a piecewise function. F of x is equal to x plus 3 if x is less than -3, 2x minus 1 if x is greater than or equal to -3 but less than or equal to 5, and x squared minus 1 if x is greater than 5. If we are to evaluate f of x when x is -1, notice that -1 belongs to the second condition, x is greater than or equal to -3 but less than or equal to 5. Hence, we use the expression 2x minus 1 in evaluating the function. By substituting, we have f of -1 is equal to 2x minus 1. Using -1 as value of x, we have f of -1 is equal to 2 times -1 minus 1, giving us the value of the function if x is equal to -1, -3. Still using this piecewise function as an example, let's evaluate f of 6. Since 6 belongs to the third condition, x is greater than 5, x squared minus 1 should be used. By substitution, we have f of x is equal to x squared minus 1. And simplifying, the value of this function when x is equal to 6 is 35. Please don't worry, these examples will be uploaded as pictures below for future references.